OW. The LOW state goes with the OUS ending. Are you with me? Maybe I should have watched Mary before I even come in here to even know if is she telling you this or is she not telling you? She talked about it. Okay. All right. So let's see here. So that's that. Okay. Now, and it's got some historical names, right? Now tell me what a plumber works with. All right. What does a plumber work with? Plumbing? Is that what you said? A plunger? All right. Well, pipes used to be made out of lead, right? Nowadays they're made out of PVC, they're made out of copper, and various other types of things. And if you know where the plumber gets his name from, is from the plumbus and the plumbook. See, that's the name, periodic table there, lead. So a plumber used to work with lead. Now, if anybody remembers, right, I guess I'm showing my age, mercurochrome, God knows. Anybody's grandmother put the mercurochrome on them? Well, it used to, I don't even know if they still make it or not, it could be illegal, who the hell knows. But mercury turns out to be a wonderful bactericide. All right, but of course it wreaks havoc on the bloodstream. Now they've got stuff like neosporin, triple antibiotic ointment, things that are a little bit less treacherous. But used to, it was a wonderful anti-infective. All right, so what's the term for mercury? Mercurous and mercuric. All right, and you ever heard the term mad as a hatter? Right, the hatter in Alice in Wonderland, and they use mercury in the refining process of making hats. Too much of it over long periods of time make it go crazy. All right, I'm serious. Like really psychologically lose your mind. And you know, used to you could buy mercury in drugstores, like a whole bottle of it, and you could just throw some out on the counter, and it was neat. Your parents have been to science class and played with it. Took it home, put it in their book bag, right? I think I was telling you guys a story about the other day. My son says, "Daddy, I got something in my pocket." I said, "What you got?" "My pet caterpillar." And he pulls out a dead worm. All right. Well, used to, people would just throw that in their book bag or whatever. Well, they figured out, well, that probably is not such a good idea. All right. Have you played with it before? You're shaking your head, yes? Played with mercury? You know, that's just the way it was. Okay, so anyway, that's what happens with multivalency. Now, are those the only 7 examples that go multivalent? Absolutely not. Those are the 7 common examples that a normal human being going into medicine, pharmacy, and that would see. Okay, and the 5th one is my loving favorite. I'm being facetious, and that's called the acids. All right. Now, how do you know something's an acid? Well, the freshman chemistry 1025 way to know something's an acid if hydrogen's written first. Okay. Now, any other chemistry professor watching this would absolutely jump up and down and cry screaming for that, right? Because if I define an acid and a base, it would take me 3 days to tell you all the ins and outs of acids and bases. But in here, if hydrogen is written first, let's call it an acid and be quiet about it for right now. All right. Now, if a hydrogen is bonded to one other atom, any random gene atom you want, maybe you want to make it bonded to HCl. Maybe you want to make it bonded to HBr. Maybe you want to make it bonded to H2S. It doesn't matter. These are binary acids. Again, bi means 2. All right, so we got 2 different atoms. 2 atoms. Now, I know there's 3 atoms here, but again, only 2 different ones. Here's what you got to do. You got to call this hydro something another ic acid. This is hydro something another ic acid. This is hydro something another ic acid. That's the general form. Hydro acid. Okay, now these are referring that these things are dissolved in water. By the way, the acids are. When you go buy HCl under the trade name uric acid at the local hardware store, you're not buying HCl gas. All right, it's mixed with water. Okay, so this right here is chloric, bromic, and sulfuric acid. So hydrochloric acid, hydrobromic acid, hydrosulfuric acid. Now let's say a word about capitalization. Are chemical names, the IUPOC, chemical names capitalized? Is there any reason why they would be? And the answer is no, they're not capitalized. If you were writing a paper and referring to hydrochloric acid, you would not capitalize the words hydrochloric acid unless they started a sentence like any other word. Okay? Now you would, however, capitalize a registered trademark like Zoloft. You would capitalize, or something like that, but Zoloft has a big long name this long, right? In organic chemistry you learn about all that. You don't capitalize those. All right. Now RNS configurations you do, but we're talking about the names. That's one type of acid. Another type of acid is called your oxyacids, right? And that means that you got yourself a hydrogen and an oxygen guaranteed and a random chain atom. Hydrogen and an oxygen and a random chain atom. Okay, what do we got? HNO3, HNO2, H2SO4, H2SO3, and let's break this one down. First off, this NO3, okay, what is that ion's name from your chart in the periodic table, in the back of your book? What's that now? Nitrate. So right here the ion ends in what? ATE. That means the acid ends in ic. So this right here is nitric acid. Capitalization, me getting lazy. All right. Now right here, this ion ends in what? NO2. ITE. That means your acid ends in us. So this right here is called nitrous acid. Okay. Now what about this? This right here, it ends in 8. That means that this is sulfuric acid. Not to be confused with hydrosulfuric acid now. Hydrosulfuric acid is H2S. This is just straight old sulfuric acid. There ain't no hydros here on these oxyacids. What's the difference? Here we got an oxygen, 3 atoms. And over here we only have 2 different atoms. Right here this is sulfurous acid. Okay? And of course naming acids and bases are extremely important, and understanding acid-base chemistry is important, right? So if you take 2046, we get into all of these acid-base equilibria and so forth. There's so many things that rely on acid bases. All right? I mean, you go to the dentist office. That's an extreme place that relies on acid-base chemistry. All right? The Novocaine is basic. So what happens if you go to the dentist office and there's a huge bacterial infection in your tooth? Will it numb good or not numb good? Why? Because the bacteria produce acid. And when acids and base get together, how do they react? They neutralize each other, right? I know we haven't been through chapter 8 yet, but it's an acid-base neutralization reaction. So is that going to work good for you? That's not going to work good for you. Now what if you go to the dentist office and you don't have an infection, but you got to get numbed up? But let's just say you are a nervous Nelly. Who in here gets to be a nervous Nelly when you go to the dentist office? One person. Stop that. Who is a nervous wreck when they go to the dentist office, right? Okay, so you go to the dentist office, you're a nervous wreck, they put the shot in there, and do you know that the more nervous you get, what happens to the pH in your blood? Does it go down or go up? What's that now? It goes down. It's more acidic, right? You're sitting there breathing very shallowly, carbon dioxide's building up. So whenever you get nervous, that lidocaine ain't going to work good for you. So that's why sometimes they'll put the nitrous acid on your nose. A lot of people think that what that does is that helps as an anesthetic. It doesn't. It helps relax you so your blood does not turn acidic, So the Novocaine